Yeah, hi and welcome to this talk. So, as I said, we are trying not to break the action only, but just decompose it, the ERP, into separate services. And you had that track with architecture. Now we are on the .NET track, and I will try to focus mainly on the .NET libraries and frameworks that we are using for this decomposition. I structured the presentation in three parts. In the first one, I will say a few words about the context, about Visma and Visma .NET ERP. Then we'll take a brief look at the changes coming ahead. And finally, in the last part will be a bit more technical, and we will look at the actual .NET libraries we are using. So the story starts in the northern part of Europe, and Visma is a Norwegian-based enterprise software company. It provides cloud-based applications that organizations can use to perform key business tasks such as accounting, recruiting, managing their supply chains, and so on. And the company's more than 1 million customers range from small businesses up to large enterprises and also some government agencies in the northern countries. So the main market are the Nordics, together with some other parts from Europe, for example, Benelux. And related to the developing of these products, there are places besides, of course, the Nordics. We have offices in Romania, in the Baltics, in Spain, and even some in South America. Looking at the numbers, Visma is kind of pretty big, and it's actually composed of several companies and a large portfolio of applications. Combined, we are more than 13,000 colleagues spread across, I think, more than 150 locations. And our software serves more than 1 million customers. As an example, there are around 20 million invoices running through Visma systems every month. In this presentation, we're going to look at the Visma .NET ERP. This is one of the ERP solutions from Visma. And by the way, ERP stands for Enterprise Resource Planning, and it usually refers to a category of business management software, a suite of integrated applications that organizations use to collect, store, manage, analyze, interpret data related to business activities. For example, the cash flows, the production capacity, orders, purchases, payroll, and many other things like this. And the Visma .NET ERP targets the large business sector, and together with all the integrated assets is the most complete cloud ERP solution from Visma. There are many modules in the Visma .NET ERP for accounting, logistics, invoicing, time registration, sales, and many more others. And besides this, there are also assets integrating with the main ERP application. Besides the user interface, there is also an API that is used by the integrators. And looking at the API calls, we could see a slight increase in the number of calls from last year, for example, from 80 millions up to 180 millions on last July. But yeah, maybe this calls, some integrators kind of made the implementations when they kind of call something in a row, so they are more or less exact. Then from a technical point of view, the main part of Visma .NET ERP is a custom framework built on top of ASP.NET. It was built some time ago, and it's not really that easy to work with it. For example, with the previous presentation, this technical depth, this monolith is a good fit for that one, but yeah, it's maybe even harder to make some improvements there. So from a software perspective, software development perspective, it's kind of hard to work with this. Then the whole shebang is deployed in Amazon Web Services in the northern region on virtual machines. And the storage part is implemented with Microsoft SQL Server, and there are several databases divided by country and by customer. Some are using the same database, some are kind of divided. Now, time to move to the second part of the presentation, looking at the changes that will come in the coming future, at least those that we planned for. Well, I had to kind of add a quote in the presentation, so yeah, maybe this one is a bit overused, but it reminds us that change happens every single day, even if we want it or not. Of course, some changes are bigger, some are smaller. We notice some of them right away, while for others, we need some more time to realize the impact. Getting back to Visma ERP, some of the challenges with the custom monolith framework started to affect the customers more and more. There were performance issues, there was no support for large sales orders, and it took longer times to maintain the existing functionality. On top of that, there is this old technology stack. So something had to be done. Therefore, the process of decomposing the monolith started. It was decided to have separate services based on domain functionality. They will communicate when needed through events and messages. And of course, they're going to be also synchronous communication, but we tried to go towards this asynchronous communication with events and messages. It scales a bit better and it's more resilient. One trade-off in order to have the process a bit faster was to have both the old and the new one running in parallel. And for the first phase, the database will remain the same. The databases actually, because there are several databases. Of course, this is like an anti-pattern when you try to split into microservices, but we had to make this trade-off to have something in production running as fast as possible, so we get some customer feedback and see how we can proceed from here on. Decomposing the monolith started with one service and then continued with the second one, the one that I'm part of, and the one that I'm going to say a few words about, and this is the sales order service. As the name implies, its responsibility is to create, read, and update sales orders. One of the main requirements from the project mandate was to support large sales orders with hundreds of lines and to have a better performance compared to the same functionality from the existing ERP. As the migration to the new service will be done in stages, it has to run in parallel with the existing solution. It should be possible to create a sales order with the new service and read it with the existing one and the other way around. So that's why we kind of use the same database. It was a bit faster. Now let's take a closer look at the technology behind this new service. In big lines, we have built a REST API deployed in Amazon Cloud or AWS, and the application is inside Docker containers managed with AWS Fargate, a managed service for containers from Amazon. The front door of the service is the Amazon API gateway, and this helps us throttle requests and mitigate some of the denial of service attacks. We also plan to use web application firewall, also from AWS, in the coming future to add some extra application layer protection for against SQL injection and cross-site and so on. As I said, we are using the existing databases and we connect to them through this VPC peering towards the main ERP AWS account. And for a better performance, we use a distributed cache, Redis, again from AWS. They offer this elastic cache service. The application is implemented with .NET 5, and we kind of plan to upgrade to 6 when it will be released. Hopefully, will happen this November. And for now, we have only a REST API, but we will start working on the front end pretty soon. And we plan to use Vue.js for this. Okay, looking at libraries, besides the latest ASP.NET framework for the REST API, we are using some other libraries. We are using, for example, the mediator pattern throughout the whole application. And for this, we take advantage of the implementation from mediator. The name is pretty the same. They just have this R at the end. Resilience is an important aspect when there are several services that communicate with each other. And for this, Poly offers some nice out-of-the-box policies covering the most common resilience patterns. Being part of an ERP, the sales order service is pretty data intensive. And to map properties from an object or a set of objects to another one, we are using Automapper. For validation, we went with Fluent Validation. And this one comes with built-in validation rules and offers the possibility to define custom new ones. For data access, we wanted to have a lighter object relational mapper, and we used Dapper for reads. But for writes, we had to use something else because we have some transactional writes that kind of span several tables, and the easiest way for us was to use Entity Framework. We didn't want to maintain some complex SQL commands. Let's take a closer look now at some of these libraries. Quick reminder about Mediator. This is a behavioral design pattern that helps you reduce the dependencies between objects. Instead of calling an object directly, the request will go through a mediator object. Mediat-R offers a simple, no dependencies mediator implementation for .NET. It's actually an in-process messaging it's implemented out of the box. And they have implemented request and response, commands, queries, events, all this synchronous or async from C#. This is how an example for a request and response looks like. The message is encapsulated in the ping class. And this class has to implement the iRequest typed interface, in this example of a string, so it will return a string, the response. The handler of the message will have to implement the iRequest handler interface of ping, that's the input, and string, that's the output, that will be the response. And in this handle, we don't do too much, it just receives the ping object and returns a task of string. And whenever you want to dispatch this message, you just have to call the send method from the mediator object, and being inside an ASP.NET application, this mediator object will be injected. For example, we are using this mediator pattern when a request comes to our controller class. Instead of calling the business layer directly, we are sending a request like this with send, and then the business layer implemented the handler for, let's say, when a new sales order is created, it will do all the work and then respond asynchronous with the result. Another example, in this case for sending notifications. As in the previous one, we encapsulate the notification in the ping class. This time it will implement the iNotification interface. And in contrast with the previous one, notifications can be consumed by several distinct handlers. In this case, we have the Pong handler implementing the iNotification handler of ping. And in this case, again, it will just write some debug line and return a task completed tasks. Publishing the notification is done with the publish method from the mediator object, sending the ping object as a parameter. And we are using these notifications in the code. For example, when a new line is added to a sales order, we want to do some additional computation with that line, like calculating taxes, calculating the counting, conversions, currencies, and so on. And each of these functionality is added as a separate notification handler. And in this way, we kind of keep them separated. Well, maybe you wonder by now, how does Mediator know what handlers to call? And of course, there is no magic involved. You have to register the handlers when you configure the service. If you're using ASP.NET Core, you can just use the extensions from the Mediator package and call this add mediator method, sending the assembly from where you have your handlers. And this will allow to register all the handlers in that given assembly. In their wiki, they have more examples. For example, how you can use it with other dependency injections framework from .NET, some more advanced scenarios, and so on. So if you're kind of curious in this mediator, do check out their wiki from GitHub. It's pretty simple and straightforward to start using it. The next library we'll look at helps you build a resilient application. In this world of connected services, we often believe that everything works fine. However, this is not always the case. Some services might be down, others might just be a bit slow, there might be some DNS cache issues, and many other things like this. Therefore, we need to write our applications in such a way that they will be resilient to problems related to other services or other dependencies from outside. And here, Poly comes to the rescue. It's a simple fault handling library, and it implements some common policies like retry, circuit breaker, and fallback. They also have this bulkhead isolation, timeout, and so on. We're going to look at an example for retry. And in this case, it also sends some context data to the method that will be retried. We define the policy, on the first line. And in this case, it will retry 3 times for internal server error and bad gateway status codes. And before each retry, we're going to log the exception and the context data that was sent to the method. The actual method that is wrapped by this retry will be called through the execute method. In the example, we pass this context in the dictionary of string and object. There are many other ways in which you can configure these retry policies. For example, you can have a duration between retries, and this duration can be fixed, can be an explanation of backoff, or it can be calculated by a custom function. Well, when a service is down, retries do not help you that much. Those retries can be seen as a wasted computational resource, and there is no point in retrying something that is likely to fail. And for these cases, we have the circuit breaker pattern that kind of proves useful. It acts as a proxy for operations that might fail. The proxy should monitor the number of recent failures that have occurred and use this information to decide whether to allow the operation or to proceed, or maybe just return an exception. An example of circuit breaker, you can see here, this will break the circuit after 2 consecutive exceptions. And in this example, it's just some exception type, but you can have your exceptions defined in that handle method. So after 2 consecutive exceptions, the circuit will be closed and it will just throw a broken circuit exception with all the consecutive calls in this 1 minute time interval. In this example, we also have 2 actions defined on break and on reset that will be called when the change of the circuit changes. And as in the previous example, the actual call is wrapped by the execute method. Note here that the circuit breaker does not orchestrate retries. Normally, you should combine this with a retry policy depending on your needs. They have more advanced scenarios on their GitHub samples, and you can see how you can combine this as well on that GitHub page. The next library helps us with input validation. Fluent validation is a library for building strongly typed validation rules. It comes with some built-in validators and allows defining custom ones. Out of the box, Fluent validation also provides some translations, but you can customize that part also. An example for validating a customer object can look something like this. Start name and for name should not be empty. Discount should not be equal to 0 when has discount property is true. Address should have the length between 20 and 250. And for the postcode, we defined a custom validator in the be a valid postcode method. So here you saw both the built-in and some custom validators. They have some more examples on their documentation, but yeah, this was pretty straightforward and simple. We wanted to kind of define these validation rules in a fluent way and a strongly typed manner. Self-ordered service, it's a pretty data intensive, so we wanted a lightweight object relational mapper. We didn't want to spend too many milliseconds just mapping these objects to their relational tables and columns and so on. So Dapper in our case did a pretty good job. And this is a simple object mapper that extends the IDB connection, and it just adds some extension methods. It's pretty straightforward to use it. You create an IDB connection object. You have to write your own SQL statements that you want to perform and pass them to this execute method together with the parameters. Of course, one big drawback here is that you have to write and maintain your own queries. And of course, you should always use parameterized queries so you don't end up with some nasty SQL injection towards your database. A simple example with 2 reading queries and 1 insert. Reading will be done with those query method, and insert is executed with execute. And one case here is that the parameter names have to match the parameters from the queries. Just pass the parameter and the query to this execute method, and the query will run it, and then it can also map back to, for example, in this example, we have order detail class that will be mapped from the SQL response. Well, this was just a simple one, but yeah, for more examples and best cases, best practices, you can go through their tutorial. Well, with that one, we kind of covered the most important libraries we are using in the sales order service. And we already deployed the service in production, but this is just the beginning in a way for us. We still need to add some more functionality and extend this API to support also the user interface when that will come. In addition to this, more parts from the ERP will be rewritten into separate services in the coming future. To summarize, I will say that the main takeaways will be to think about fault tolerance from the beginning. And you also should not trust the input and always use input validation. And you could consider a lightweight object relational mapper, test it, and if it does the job well for you, then you can stick with that. If not, you can go to something more powerful like Entity Framework, for example. But remember to always use parameterized queries. Well, thank you for listening. And now that you know Visma a bit better, we hope to know you as well. You can check out our open positions and get in contact with us. That was my part. I think maybe we have some time for questions or some thoughts on this. It went a bit faster, so yeah. I guess they didn't expect to end so fast.
Yeah, we're here.
Yeah, great.
This was quick and effective.
Yeah, I didn't want to get too much into details. It's 5 o'clock, and yeah.
Absolutely.
Just
Okay.
the main points.
I'm really interested to understand a little bit. Okay, from a technical perspective, we kind of got it. We will have more questions, of course, but from a team perspective, I mean, how have you organized the things, and how do you get people prepared for such a change, because it's a change.
Yep.
And change is probably the most dramatic thing that can happen in organizational life.
We are a separate team from the main one. So there is the main team that kind of handles the main ERP, and that one kind of runs in production. It has customers and so on. And then we have smaller separate teams for rewriting parts of this ERP. And we are kind of separated.
To me, this sounds even more complicated when you add another team to do like the nice, fancy, trendy type of work. In a way, or maybe it's just like the way I see it. But yeah, please dig into the details, because I'm really interested to understand.
Yeah, you kind of need both of this, because we want to support also the existing one, and moving to this new part will take some time, and maybe not all customers will migrate from the beginning. And of course, people probably will like to join these new teams slowly, but they are also needed in the existing teams. Yeah, we have, like, for example, a business analyst that also works for the main team, and he also came to our team to explain the functionality and to tell us what has to be done where, and explain a bit of the database structure and so on. So we have some people that are kind of cross teams, let's say.
Okay. And how do you onboard a new person in the fancy team, so to say? Because people.
Yeah, it can be seen as fancy, but it's just another team.
Yeah, it's just my wording. I mean, you're not calling it fancy. I call it fancy.
Yeah.
No worries.
Yeah, onboarding is not that Complicated because this is a small service. So the code base, it's pretty slim right now. So they just have to go and look at the structure and yeah, just goes ahead. We actually kind of have 2 new colleagues. They started in August. And after 1 month, something, they kind of do tasks and they are deploying code in production. So it's a bit easier. That's one of the advantages of having separate, smaller services. The code base is easier to understand. And we say that it's easier than the other one, but maybe after a couple of years, this also will become too complicated. And yeah, we have to split more. But yeah, this is how it is right now.
And what is your approach? So you want to, after this new system has certain maturity, then you want to onboard new customers here, or then you slowly want to replace the other one?
We have to onboard slowly into this new one. And yeah, probably they're going to run in parallel for a couple of years, maybe. But we don't have a clear roadmap, but yeah, they will have to run in parallel.
Okay. We have a question from the audience, from Mihai. It's regarding the spec flow. So do you recommend using spec flow and fluent assertions for no-fault tolerance?
I cannot say too much. I haven't kind of used spec flow, so not really know what that is.
Okay, no worries. I cannot say myself, to be honest.
I guess it's some sort of domain.
Yeah.
For validation.
Yeah. Okay. The answer is we'll think about it and we'll get back to you. Yeah, because I also don't know what to say. All right. Okay. So the one thing that was not clear for me. So are we speaking about a product which is deployed on a hybrid cloud, or is it just on AWS?
It's only AWS. It's only AWS on the northern region right now.
Okay.
We just have separate accounts. So the main ERP has an AWS account, and we have a separate account for our service. And that's why we had to create that VPC peering between accounts.
I understand. Okay. And any plans to, I don't know, not maybe moving, but I don't know, offering a similar solution with native services and possibly Azure, or?
We haven't kind of thought about that too much.
So from a deployment perspective, AWS is like a decision. That's it.
Yeah, for now at least. Yeah, this is so it is.
Because I'm thinking of the advantages of native services in the cloud, as opposed to just deploying an infrastructure and building applications which are deployed on those VMs or.
Yeah, so native, I guess you are referring to kind of serverless, Lambdas, and DynamoDB and stuff like this. For database, for example, we are kind of stuck, let's say, to the existing ones, and then you have to use that one. And for computation, we went with containers because, like comparing with Lambdas, we said that our call or the code will be pretty used, so the application will have a lot of calls. And then it will make a bit more sense for us to have containers running all the time comparing with functions. They're going to scale down probably at night, but during the day, yeah. And we had some tests with cold starts, and for some cases didn't went pretty well. So
okay.
Might be also this thing that we are kind of used with containers, and this was like the first thing that we jumped to. And these Lambda functions and serverless solutions are a bit newer for us. We have some smaller functions, but they don't kind of serve for the main functionality of the application.
Okay, I got it. Okay, Cristian, then any final recommendations for anyone in the audience who wants to break the monolith and or decompose it?
Yeah, they kind of should think of why they're doing this, and it's a bit hard to define the how to say this, the functionality. Where should we break it? What should be the domain? How big should the new services be? How small should they be? this is like a pretty common question, and I don't think there is like a straightforward answer. Everyone is kind of.
It depends, right? It's
It depends
the
on
classic
them.
the
So,
classic. Exactly. Okay.
and you're gonna end up with more services, more things to handle. So you also have a disadvantage here. So you should have a really good, how to say, something to win after breaking this service into services. Then just don't do it because everyone is doing it. Just kind of analyze before and make sure that that's helpful for you. So, yeah.
Makes sense. Makes sense. No further questions from my side.
Yeah, that's indeed very good advice when you're thinking of switching from a monolith to individual services, especially since maybe a modular monolith can be good otherwise.